All right, here's a little review sheet just for extra practice, getting ready for this Chapter 7 test, and I want to work through these problems with you. So this first problem involves graphing a rational function, and to begin with, I'm going to go ahead and square this numerator, expand it out to the three terms, x squared minus 8x plus 16 over x plus 2. And from there, I'm going to can look at both of these actually for information that I'm going to need. So let's start with zeros of the function, or x-intercepts. And the way I know if we have any x-intercepts is I take the numerator, make it equal to 0, and you can take either one of these, really doesn't matter, but it's easier, of course, to deal with the original. When you solve this, squaring both sides, you get x minus 4 is 0, so x is 4. So I know that my graph is going to cross the x-axis at x equals 4. All right, and so let's move into the area of asymptotes. We'll start with any vertical asymptotes that we may have. Those are numbers that cause the denominator to become 0. If we replace x with those numbers, and there's only one in this case, so I'm going to have a vertical asymptote at x equals negative 2. All right, horizontal asymptote, I'm not going to have one of those because the degree of the numerator is larger than the degree of the denominator. What about an oblique asymptote? The degree of the numerator is 1 more than the denominator, so, and there's nothing that can be canceled. There are no common factors, so that means I am going to have an oblique asymptote, and I'll find it by doing long division. So divide first term in the first term, that goes x times x squared plus 2x, subtract. This makes 0. Negative 8 minus 2 is negative 10x. Bring down the plus 16. And now repeat. X into negative 10x goes negative 10 times. Negative 10x minus 20. And at this point, I know I can't divide any further because I'm going to be left with a constant. So my oblique asymptote is going to be the line y equals x minus 10. Now I'm going to hold off on graphing that, and I'm going to go ahead and generate some points just so I can see the kind of numbers, how big the y-axis numbers are going to be. I'm not going to change the x-axis scale, but I probably will end up changing the y-axis after I've generated a few points. Okay, so let's see then, we've gotten all three of our asymptotes checked. Let's see if we have a whole. And a whole is a number that makes both numerator and denominator 0. Don't have that in this case, so we won't have to worry about plugging a hole in our graph. So now let's run through some points, and then I'll sketch my oblique asymptote after I've looked at some values for y. So let's see what happens to the left of negative 2. If I plug negative 3, and you can use either one of these, you can use either the original or the expanded. I think probably the original would be easier. And I'm going to go through this pretty quickly. I've already generated this table. If you input negative 3, you get negative 49. If you input negative 4, you get negative 32. Negative 5 gives you negative 27. Hopefully you've verified that yourself. You're able to use your calculator correctly. So because of these numbers on the y-axis getting fairly large, I'm going to do my y-axis in 5s. And now that I know that, I'm going to go ahead and sketch this oblique asymptote. So it has a y-intercept of negative 10. You have to be careful here when you're counting out the slope when you've changed one axis units but you haven't changed the other. So this would be like going up 5, and then I'm going to go right 5. Because 5 over 5 equals 1. All right, and I'll just do that again. Down 5, left 5. And let me just draw a line through those points. And we'll make this dotted. All right. Okay, so that's going to be our oblique asymptote. And so now we can start plotting some points. So for -3 on the x, we go down to 49, so that's 5, 10, 15, 20, 25, 30. This is 50, so it's just about to 50. Okay, so for -4, we go -32, and just a little bit lower. And for -5, -27. This is 25. And I can kind of get an idea. It's going to curve around, and I'm just going to use my oblique asymptote as a guide and this vertical asymptote as another guide. And that is going to be the graph of one of the sections. And now let's continue on making our table for the right side of this vertical asymptote. So you can choose numbers like 0. If you let x be 0, you should get a y of 8. 5, this would be 10, so just a little bit below. If you do -1, you get an output of 25. So -1, and then 5, 10, 15, 20, 25. And I think that's probably enough. We're going to be drawing through these points. We already knew that we're going to cross the x-axis, and we'll stay within our asymptote lines. And it looks something like this. All right, and that's the graph of this rational function number 1. Okay, number 2 is a word problem involving inverse variation. So we're told that a concrete supplier sells premixed concrete in 300 cubic feet truckloads. Area is inversely proportional. All right, so remember what inverse variation looks like. And we're supposed to use A and D as our variables. So in general, to show that area is inversely proportional to depth, we would say this: A is equal to K divided by D. Area is inversely proportional to depth. And now let's get a specific number. We know that since it's sold in 300 cubic foot truckloads, they basically told us what the number for K is. So I can replace K with 300. So that's my answer for letter A. Pretty simple. This is an example where you didn't have to figure up K. It was actually handed to you. If they had told you that area is a certain number when the depth is a certain number, then you would have had to solve for K. But that's not the case here. All right, so letter B, what is the area? In other words, what is A if the depth is 0.5 feet? So we just plug in 0.5 for D. 300 divided by half is the same thing as 300 times 2. And remember, area is always represented in square feet. So we would say it's 600 square feet. All right, and so that's your answer for 2, A and B. So let's work on number 3. We need to factor these denominators so we can come up with the LCD. So there's the left denominator factored, and here's the right one factored. And coming up with the LCD, we're going to combine these basically, and we don't have to repeat any already common factors. So there's the LCD. Write it twice, and we'll divide into each one. Okay, I'll just bring down the 2x and the 4x. All right, so I'm going to divide the original factored form, original denominator, into the LCD. and x minus 1 is not canceled. So it's like I'm going to multiply 2x times x minus 1, and that's 2x squared minus 2x. Over here, x plus 1 doesn't cancel, so I'm going to multiply 4x times x plus 1, and I get 4x squared plus 4x. And don't forget, when you're subtracting, you're really subtracting both of these. So 2x squared minus 4x squared, that's negative 2x squared. And negative 2x minus 4x is negative 6x, all over the, I'm just going to say the LCD, because I'm going to go ahead and factor this. Remember, if you can factor the numerator, you need to. It's safer, even though in this case I can't cancel anything between the numerator and the denominator. If you don't factor, you will miss out on those opportunities when they arise. So this ends up being my final answer, negative 2x times the quantity x plus 3 over the LCD. Okay, and I think we have one more. This is an exponential equation, base e, so it needs to be changed into a natural log equation. And as a natural log equation, we would say natural log 30 equals the exponent, x plus 1. In your calculator, you'll do natural log 30, and you can see that decimal there. I won't write it down, but I'll read it off. It's 3.401197382. So the easiest thing to do is just leave that decimal sitting there, and we need to subtract 1 to solve for x. And we'll just go ahead and round this to 10 thousandths. It's 2.4012 is our solution for x. And that is this little mini review sheet, just giving you a little extra practice on a few types of problems where people have had some questions. And practice hard, work hard for this test, and let me know if you have any questions.